Hi all, today's topic is analytical function. In this, the first problem is nothing but an analytical function whose real part is constant and must itself be a constant. Okay, if it is a real part is constant, then it should be a constant. Then the function itself, it's a constant. So that is the meaning. For example, it can be rewritten. The statement can be rewritten. It's nothing but f of z and f of z bar are analytical function of z. Then prove that f of z is a constant. They may ask any, both are same only. They may ask in any format. So what it is given, analytical function real part is constant means we know that f of z is nothing but u plus iv. F of z bar is nothing but u minus iv. So f of z is analytic means CR equation is satisfied. CR equation satisfied means dou u by dou x equal to dou v by dou y. Dou u by dou y equal to minus dou v by dou x. Same concept. If f of z bar is analytic means same CR equation satisfied. Only change in the minus symbol. Here plus, here minus symbol. So in the formula, if I don't have minus, I have minus in this. I have minus means plus symbol. So the same set of formula, we can write it. So what it is means, I can add or I can subtract. I get a two set of equation. I have to prove f of z is the constant I have to prove. So what I'm going to do, subtract your 1 minus 2 when I do it. Left, check your left 1 minus 2 when I do it. This minus this when I do it, left equal to 0. So right I will be getting 2 times of dou v by dou y in the first set of equation. Same with the second set, the same subtraction if I do it. So again the left equal to 0. Right I will be getting 2 times of dou v by dou x equal to 0. From the both the conclusion, v is nothing but constant. It may be with respect to x or it may be with respect to y. When I integrate it both the side, both side integration when I do it, here 0, so I cannot do it, it's like a constant. So v equal to constant 1. Same way when I add, so right hand side will get cancelled, only left it is 2 times of dou u by dou x equal to 0. Same way in the second set of equation, dou u by dou y equal to 0, I am getting u equal to C2. We know that f of z is nothing but u plus iv. Generally f of z, f of z means how can I write? It's nothing but u plus iv. U and v are now calculated. U is nothing but C2 constant. V is nothing but C1 constant. So that only I have written C2 plus I C1. So any constant plus I into another constant, it's nothing but constant. So f of z constant. We have proved. So this is like a property. In some book it will be mentioned as a property. Some book they will tell as a problem also. So whatever it is asked, we can prove it. The second problem, if same concept only. So if f of z is an analytical function with constant modulus, show that f of z is constant. Okay, constant modulus if it is mentioned, the same concept only. So constant modulus that is mentioned. Constant modulus is different, real part is different. Okay, so say answer is same. F of z is constant, we have to prove. We know that f of z is nothing but u plus ib, and we know that f dash of z is nothing but, so differentiation with respect to x, so ux plus I as it is vx. Okay, so modulus when I take f of z, so modulus what we do, modulus is nothing but constant. So modulus means square root of u squared plus v squared equal to constant. So square root if I remove, u squared plus v squared equal to c squared. I will have this as a equation 1. Okay. So this f dash of z, same way I take a modulus means f dash of z nothing but it is ux squared plus vx squared, this whole square root, correct? Ux squared plus vx squared. So I have to remove modulus means f dash of z, the whole squared is nothing but ux squared plus vx squared. I'll have this as second equation. I'll be using this 1 and 2 later. First, this first equation I'll differentiate with respect to x, partially with respect to x and partially with respect to y. I will have two set of equation. So that first I will do. Differentiate this first equation with respect to partially we are doing partially because Not normally we cannot do because I have a two variable. So with respect to x, when I differentiate, same way the same first equation partially with respect to y. So what I will be getting, so it is partially means 2u u square differentiation 2u ux plus 2p vx constant, it becomes 0. So it is nothing but ux plus vx equal to 0. 2 is divided. Same way when I do with respect to y, 2uy plus 2vy equal to 0. So 2 divided, so I'll be getting uy plus vy equal to 0. So I'll have this as a third equation and this as a fourth equation. So what I'm going to do now, f of z is the analytical function. So it is given in the question, what it is given. F of z is an analytical function. F of z analytical means CR equation satisfied. Correct? No. So f of z is analytic. It's given in the question. It's an analytical function. Given. This is given. Okay. If this is given, CR equation satisfied. CR equation satisfied. So what is our CR equation? Satisfied. So ux equal to vy and uy equal to minus vx is the CR equation. Now substitute this in the fourth equation. So what you will get? So u as it is, instead of uy I'm going to substitute vx minus vx plus v as it is, vy I'm going to substitute as ux equal to 0. I have this equation, I'll rewrite again, u into vx plus v into ux. This equation as fifth equation. Already I have third equation, I did not use the third equation. What I am going to do, squaring and adding the third and the fifth. 3 squared plus 5 squared I am going to do. Squaring and adding. So when I do it, so u into ux plus v into vx the whole square plus minus u into vx plus v into ux the whole square. Why, you may ask question? Why, ma'am, you have changed? The reason, you would see after I do it, what before it was in terms of x, in terms of y. Now my new equation in terms of x I have changed. After using a CR equation, it becomes to be a x variable. Y removed at all. So that reason only I am doing that. Okay, so I removed this y term, so because of that I have done. So simplify this. Okay, after simplification we get one term, so that from that only we have to bring f of z as constant. So now, so simplify it, u squared ux squared plus v squared vx squared plus 2 times of u v ux vx. Same with this, u squared vx squared plus v squared ux squared minus 2 vx and ux equal to 0. This both get cancelled. So I'll be getting 2 times, correct? No? So ux squared and vx squared is 2 times of vx squared. So what, which time I can take it outside, means u squared plus v squared I can take it outside. You check. So in this you check, u squared taken outside. So it is ux squared plus vx squared. Same way v squared I can take it outside, ux squared plus vx squared equal to 0. Now this both we have to simplify it. So it's nothing but u squared plus v squared into ux squared plus vx squared. Already we know that, I will show you that equation, ux squared plus vx squared, where we have done in the starting itself we have written. Check, ux squared plus vx squared equal to It's nothing but modulus of f dash of z the whole square. So that from a 2, I'm going to replace that with respect to second equation. This is by equation 2. So what it happen, u squared plus v squared is nothing but modulus of f dash of z the whole square equal to 0. We know that u squared plus v squared already from equation 1, v squared plus u squared equal to, from equation 1 it is a constant, it is not equal to 0 by equation 1. So it is the meaning, this is I can it is like a constant, so I need not write constant into anything, so it is same only, so no need to write, we can remove that. So it is nothing but f dash of z the whole square equal to 0. Whole squared I can remove and write it. It's nothing but whole squared, when I remove and write it is nothing but f dash of z equal to 0. So f dash equal to 0 means modulus also I can remove it. It's nothing but f dash of z equal to 0. So what is the meaning? F of z equal to constant. See, it is nothing but constant. That only we need to prove, we have proved. They may ask like this, any property. So we have to bring, think the concept, and according to that we have to bring it. So I will go with one more problem. The same method, but it's a different case. Analytical function for a problem 5. If f of z is nothing but u plus ib is an analytical function of z, and show that some equation is given. Left equal to right. So the verification and all, when left equal to right means we can bring it. Left we have to bring to the right. So what is generally f of z is nothing but, it's an analytical function. It is nothing but u plus ib. So modulus of f of z is nothing but u squared plus v squared. So it's a whole squared, it's a f of z. The whole squared is nothing but u squared plus v squared. That I will take it to some other variable 5. We are only taking here 5. So now every variable I'm going to convert. This whole f function I'm going to convert it into 5. Then finally I can replace it. It's not wrong. Okay. So now all the term. So I have to find second order with respect to x and second order with respect to y. Before that I will find first order first. Dou phi by dou x I need to find. So this is my u square plus v square is my equation. So when I differentiate one time, dou u by ux plus 2v by vx is my answer. 2 I can take it outside, it's nothing but ux plus v px is my first order derivative. Same way, dou phi by dou y, when I do it, it is 2u into uy plus 2v into vy. Same way, 2 can be taken outside, u into uy plus v into vy. So now I have to do second order equation, dou square phi by dou x squared. This equation with respect to one time with respect to x. So when I do it, so I'll be getting 4 terms. So it's like a uv. Okay, so 2 times 2 taken outside, u I am keeping as it is, so uxx plus ux I am going to keep as it is, u if differentiate ux, and v same way, v I am going to keep v double x, and vx going to keep as it is vx. So simplify this. So it's nothing but 2 times u into uxx and ux squared plus v into vxx plus vx square. So same way, dou square phi by dou y square, when I do it, same concept, you can write it because it's the same only you are going to get, but in terms of y. So that is why I am not doing. Okay. So the same thing I can replace it y. I will not get a different because I have the same variable only. Only y will change. So I am writing as it is. So now add, this is first equation, this is my second equation. When I add, I will get my left hand side. So that I will do it. So left, when I add, dou squared phi by dou x squared plus dou squared phi by dou y squared. When I add it, I will be getting 2 times of u is taken outside, uxx plus uyy plus v same way taken outside vxx plus vyy. Same way ux squared plus vx squared plus uy squared plus vy squared. So now what it has been means uxx plus uyy, it's nothing but it's a 0. So this is 0. Same way vxx and vy, because why it is 0? The reason it is a harmonic function. Analytical function satisfied means it is a harmonic function. Second order derivative, it is 0. It is 0. The reason is harmonic Laplace equation satisfied. Laplace or harmonic or regular function. So any term it can be told. So it is nothing but it is 0. This also 0. So I'll be getting 2 times of ux squared plus vx squared plus uy squared plus vy squared. So we know that ux squared plus it is nothing but what it is. Now only we have written modulus of f of z. I will show you again at the top starting we have written. So what we have written, check here. So u squared plus v squared we have written modulus of f of z. So same way now. So it is 2 times of modulus of f dash of z whole square plus y variable also same thing, f dash of z, one with respect to x, one with respect to y. Like that we can write this fully with respect to x, this fully with respect to y. Both it is a f dash of z only. So it is nothing but 2 times. So again already 2, so 4 times of f dash of z the whole square modulus. So what I have taken, left I have taken the question left as it is. F of z I have taken to be 5. Okay, same question only 4 times of f dash of z the whole square. I have proved it. So that only we have to prove. Like this only we have to bring any whatever the question it is asked, any proof, we have to take the left and bring the right hand side using whatever the concept we know. Thank you.